Hello, in this lecture I will talk about the stars in the visible universe. The closest star to Earth is the Sun. The Sun is about 150 million kilometers from the Earth, and it takes the Sun's rays 8 minutes to reach the Earth. Any celestial body that emits light and heat as a result of nuclear fusion is defined as a star. And that is why our Sun is a star, whereas all the celestial bodies that rotate around stars, like the Earth orbiting the Sun, are defined as planets. The next closest star to Earth other than our Sun is Proxima Centauri, found at a distance of 40,208,000,000,000 kilometers from Earth, or 4 light years from Earth. That is the light emitted from the star Proxima Centauri that moves at a speed of 300,000 kilometers per second. It takes 4 years to reach the Earth, or in other words, it takes light 4 years to travel a distance of 40,208,000,000,000 kilometers. And that is why I told you that if theoretically there was a wedding on the star Proxima Centauri, and the wedding was broadcast live to Earth, if you see those pictures of the wedding now in 2023, it actually took place in 2019 because it took the pictures 4 years to get from Proxima Centauri to Earth. And that is exactly why I said that when we look at the stars, we are actually looking into the past. So a star or a sun is a spherical celestial body composed of matter in a state of plasma and gas aggregation. A star, unlike a planet, produces its own radiation by nuclear fusion and emits it into outer space. The source of the energy released from stars is nuclear fusion, and it is emitted into the space in the form of electromagnetic radiation and neutrino particles. According to estimates, there are approximately 7 times 10 to the power 22 stars in the visible universe. Other estimates speak of at least 10 to the power of 24 stars. The stars in the universe are not uniformly distributed but tend to accumulate in structures called galaxies, which in turn are organized into structures of galaxy clusters and superclusters. I will explain what is a galaxy. A galaxy is a collection of stars that are bound together by gravity, and they all revolve together around the center of the galaxy. For example for a galaxy is the Milky Way. The Milky Way is the galaxy in which the solar system is located and in which the Earth is located. The diameter of the galaxy of the Milky Way is about 100,000 light years. It is about 1,000 light years thick, and it contains about 200 billion stars like the Sun, and according to some estimates, up to 400 billion stars. The stars of the galaxy revolve around its center at a speed close to 220 kilometers per second. We will explain what is a galaxy cluster. A galaxy cluster is a collection of many galaxies held together by a common gravitational force. A galaxy cluster can contain between hundreds and thousands of galaxies. We will explain what is a supercluster. A supercluster is a group of several galaxy clusters and galaxy groups together. The existence of superclusters shows that the galaxy clusters are not equally distributed in the universe, but are united in groups of superclusters. Superclusters are between 100 and 400 million light years across and can contain several thousand clusters clustered nearby. Superclusters are also united in structures called great walls, which are grouped together and move through the universe as one unit. The Great Walls are the largest structures known to us. The Sloan Great Wall was until January 2013 the largest known structure in the universe and is now the second largest after huge LGQ. Huge LGQ is 1.37 billion light years long, and it is 1 billion light years away from Earth. We will talk now about the birth, course of life, and death of the stars. The stars are born inside the molecular clouds of hydrogen when a supernova explosion or a collision between two molecular clouds causes the compression of parts within the cloud, and the process begins in which each of these regions is drawn to its own center of mass and contracts, and due to the compression the core of the region heats up. This stage is known as a pre-star. The prostar continues to gradually contract under its own gravity, and the temperature in its core continues to rise until it is high enough to start nuclear fusion processes in the star's core, which produce a lot of energy and work against the contraction. thus creating a stable star. And in this case of extremely large stars, a pulsating star. The star spends most of its life as its core fuses hydrogen to helium. This phase is referred to as the phase where the star is in the main sequence and will be largely stable. The duration of the star's stay on the main sequence is determined by its mass. When stars with a small mass, such as a red dwarf, can remain on the sequence for tens or even hundreds of billions of years, while very massive stars reach a state in only millions of years where the accumulation of helium in the core reaches fusion and begins the next phase. An average star similar to our Sun will be on the main sequence for about 10 billion years. After the hydrogen in the star's core runs out, fusion of the helium in the core begins. The fusion of the helium hits the hydrogen shell near the core, and hydrogen fusion begins around the core. Fusion in the mantle greatly inflates the star, but its surface temperature drops. The star becomes a red giant whose surface temperature is low. After this stage, the continuation of the star's life depends on the mass of the star, and in the case of double star system, also in the state of development of its partner. The star, which has ceased to fuse hydrogen in its core, is already set outside the main sequence. In low mass stars, helium fusion will begin in its core, but this process will destabilize the star, and eventually the outer layers of the star will dissipate, leaving behind nothing more than a white dwarf. Extremely small stars with a mass of less than half the mass of the Sun, after completing hydrogen fusion, will slowly die out. The fate of these stars has never been observed by astronomers because the lifetime of low mass stars is greater than the age of the visible universe. In medium-sized stars, which are only about half a solar mass and up to about 1.4 solar masses, that is the Chandrasekhar limit, after the red giant phase, when the hydrogen in the star's shell runs out, they will begin to collapse in on themselves until the conditions in the core are suitable for helium to carbon fusion. At this stage, the star will heat up more and more, expand in what is called the helium flash, and when the helium runs out, the star will shed its outer layers, which will turn into a planetary nebula. The carbon core of the star will collapse and become a white dwarf made mostly of highly compressed material. A centimeter cube weighs several tons. In massive stars which exceeds the Chandrasekhar limit after the completion of the helium fusion processes described above, the star will contract again and the temperature in its core will increase even more. Due to the high temperature, additional nuclear processes will begin in the core, in which elements such as oxygen, magnesium, silicon, up to iron will be formed. In fact, the star will become composed of layers upon layers of different elements, similar to onion skins. The mass of the iron core will increase, and when it passes the Chandrasekhar limit, the core will rapidly contract and the outer layers of the star will be blasted into the space in a type 2 supernova explosion. The star itself will collapse into a neutron star, or if its mass exceeds 3 solar masses, it will collapse beyond that, becoming a black hole. Thank you very much.